Hello everyone, this is a video lecture for Pre-Calculus Chapter 2.7. So I don't have a title, I'm sure your homework does, but I want to tell you about these video lectures that we're going to be doing here together. Basically, I'm just making an informal lecture class experience here. So, whatever I would do in class, I'm doing it here. Obviously, there won't be any questions during the video, but you can always ask me questions later via an email or Blackboard message. My drawings are not going to be the best. My graphs are not always perfect, but I'm going to do the best I can. A lot of times when I go through the homeworks here, I'm certainly not going to be doing every single homework problem. But I do choose good ones. I want to choose different ones. I want to choose things that are important to you and things that you'll probably see again later, and things that are just hard to understand and like, what are they wanting here? So that's the point of these, is to get through the homework together, and so that way you can learn and also leave homework for you to do. That way you can learn for yourself and kind of practice, I guess you could say. So that's what we're doing here together. We're practicing math. So I'm going to just jump right into this section. I think it's about composition and functions being added, subtracted from one another. Lots of little things like that. So I'm just going to do it. So 2.7.001. Now, before I keep going, I want to talk about my numbering system here. This question is on your homework. It's on your homework for chapter 2.7, obviously, but it's not necessarily your number one question, your question number one on the homework. It's not necessarily that. It could be. I mean, probably is in this particular case. But like the next one is 009. Is that going to be question 9 on your homework? No, it could be question number 2 for all I know. I didn't really number them like that. I don't care about what number it is on your homework because sometimes they even mix it up a little bit. Rather, I'm showing you what the question ID number is that they reference from the book. Okay, so if, let's just say you wanted to go and pull out your ebook, you would go to chapter 2.7, question number 1 in the back of that section should be this guy. And so you could go and kind of reference that and do stuff like that if you want. So it's just a different way of doing it. Is your book required to do this? No, not at all. Everything is on the webassign homework. It even gives you a link to click on, like read it now or something like that, a button that you could just go to the ebook if you want to, but not required. I'm going to show you everything you need here, and we're just going to do math problems. So don't go to the ebook necessarily. I'm just saying that's my numbering system. So now that you know, let's do this. So I have my first graph here. It kind of does this little wobble thing, and then there's like another little wobbly thing kind of like that. This is supposedly F, and this is G. Let's call this 8, x equals 8 here. And again, this is not going to be perfect. This here, oh, I did it a little too low. That's okay. I'll just do it right there, let's say. Let's say that height right there is 3. And right here, same 8. Let's just say that height right there is at 4. Okay, now you might have different numbers. You might have a different graph entirely, but you're going to have a graph. You're going to have some numbers. And I'm coordinating it off with the 8 because 8 is what they're going to be asking for. Okay, so 3 and 4 are the heights of F and G at x equals 8. Okay. What do they want in this question? Well, they say find F plus G at 8. Looks just like this. That's what it looks like. So what do I do? Well, I'm looking for the y values at F and G at 8, and I'm going to add them. So, well, we got 3 plus 4 equals 7. Ta-da! That was it. Very simple. F minus G at 8. Well, notice now I'm just going to say the F value, it's 3, minus the G value, it's 4. Makes a negative 1. What about FG, when they just kind of like put them right beside each other? Well, that's F times G is what that is. And so then when you have 3 times the 4, hopefully you're seeing a pattern here now. And then finally we got F divided by G at 8. And so then I got 3 divided by 4. Well, and that's already simplified, so there you go. Super easy problem. And this is a review, so this should be familiar. Might have been a while for you or not, I don't know. But Certainly, we've talked about this in the college algebra class that you've had before this class. Okay, so I got an f and I got a g, and they're wanting the same thing, but notice that this time it's going to be functions. They say in terms of x. So I'm just going to take what I have for my f and add it to my g. F plus g. Well, you know, we're going to simplify, of course. We don't need the parentheses. So like these two combine to make a 2x squared, and then plus an x, and we are good to go. That was it. Find f minus g. Now, I'm doing all of these just so that we can say that we did them. Sometimes I might skip some parts of problems, in particular if they're boring or just repeats, you know. Notice here that we got a positive and a negative. So, like, you're not distributing. It's just that one's negative. And so you're going to cancel these guys out. And, well, you just get a plain old x. F times g. Also notice that I'm using the parentheses. I wouldn't say it's required here. I think it's a good choice here. And here I'd say it's a very good choice. And almost necessary. So I'm using parentheses just so that I can know that I'm doing it right and all that stuff. Well, don't like try to, you know, distribute this way or FOIL. It's just this one term distributing. And so we got x to the fourth plus x cubed, and you're good to go there. F divided by g, same style. X squared plus x all over x squared. What they all have in common is an x. You can factor that out to the front if you like. Something kind of like this, and cancel. There's numerous ways to do this, but I'm just showing you one basic way. I don't do this method myself very much, but there you go. For each one of these, they actually ask for a domain, okay? And I can't remember if they wanting the domain like right after this and that, but let me tell you, the domain on all of these here so far is going to be negative infinity to positive infinity, okay? That's your domain for these three right here in particular. The reason why I'm asking myself, and this is something I do with my college algebra classes, I ask, do I have division? Like, let's just look at this guy. Do I have any kind of division? And I would say no. Well, then, okay, whatever. Do I have any square roots? And I would say no. I have a square, but not a square root. Remember, square roots, they look like that with, like, x's on the inside. I don't have any of those guys, so don't care about those guys. Well, there's no domain restrictions. There's no problems to look for. So negative infinity to positive infinity is the default answer, I would say, in all these cases. Now, let's look at this guy right quick. I'm going to ask you, is there any division? You're going to say, yes, there is division here. Notice that we have something in the denominator. We have a denominator at all. And so I'm going to take the bottom equals 0 on the side. This is my procedure. X equals 0. There's no simplifying. It's just that. This right here, that's a vertical asymptote. You could also say it's like a hole in your domain. I'm not really caring that much at this point. We're just saying, hey, what's the domain? And so I'm saying, okay, I can't have 0, but I can have everything else. So negative infinity, go into 0, union, 0 to infinity. Notice the U, union. I'm pretty sure that you can't just type a U into webassign. You have to actually have the union symbol. And on most problems, they'll have blah, blah, blah text. They'll have a box. And then like way on the side here, they have like a little pop-up menu thing. And you got to click one of them and drop it down and find the union symbol and all that kind of stuff. Another way, just for expediency's sake, if you're very good at typing or if you have a full keyboard or something, I'm pretty sure you could actually just type the word union and it just goes bloop and it just pops right up. With a union symbol. Same with if you do SQRT, it'll just pop up with the square root. Pretty sure about that. I can't remember. I remember that, see, y'all have been in algebra. Y'all have taken the My Math Lab course. In My Math Lab, I'm sure you have to do that slashy sign before it, and then it'll work. But I think in WebAssign, you just type it straight up, and it just happens. I can't entirely remember, but I know there's a way to just get it working like this. So just, test it out. Try it out for yourself. If you don't even like doing it, then just don't do it. Click on the thing over there, okay? Cool. So that was it for that, okay? Just a nice review on domains and stuff. Let's just say if I had a square root, So I'm going to just write this on the side here. If I had a square root, what would I do? Like here in this particular case, I have no. But if I did, I would look at the inside of that square root and set it equal to 0, and I would be finding a start point. A start point. Just like we were finding vertical asymptotes or holes there, I would be looking for a start point, or end point, I guess, that way. We'll probably see that here later, so, and if not, well, then not. So, next question, 2.7.015. I got f of x is equal to 6 over x. I got a g of x is equal to 8 over x plus 8. Okay. Same thing. F plus g of x, what does it equal? Now, I'm going to do something funny with you here. Okay, something that you probably don't even realize. I'm going to actually put f plus g in the box. Check. Like, it does work. I'm telling you, it works. Now, you're thinking, oh, okay, of course, it works. Duh, you're doing an f plus g. You put them in, you're good. Well, notice here that I'm not simplifying. Notice that I'm not simplifying. Let's go back up for a second. Right over here, this dude right here, this guy, I simplified him. Did you see that? All the other ones I really didn't simplify very much. But this guy actually did my own little simplifying. It could have been 1 or 2 steps, whatever. That's fine. And you can simplify. Or you don't have to. So you don't have to simplify in webassign. Okay? Now, I know for sure that MyMathLab, what you're coming from, requires you to simplify on every single problem, every single part. You do not need to do that anymore. You're in pre-calculus. You're going to go on the calculus here, all using webassign. You do not have to simplify. Okay? Now, it's a good idea to know how to do it and to do it sometimes. And I will do it occasionally. But I also want to make a point here right now. The first section, I want to tell you, you don't need to simplify. Okay. So, like, if they say minus sign, what do we do? Well, I mean, you do the same thing, but you put a minus sign in there. You don't need to simplify. Just leave it alone. They're asking for it. We give it. That's fine. We're done. How do I do this one? Well, I'm going to use parentheses. I'm sure there's other ways to do it. Heck, you can even simplify it if you want. But, I mean, that's it. We're good. Check mark, check mark. If this is not working for you, then you need to tell me. In fact, it's kind of funny. On every single problem, at the very top of the problem, like, let's just say this is your problem here. You're looking at a webassign. In one of the corners, it says, ask my instructor. I think it's ask my teacher, maybe. I can't remember. Ask me. So ask my instructor, ask my teacher, something like that. You click the button here, and you type a little message or whatever, and you send it. Well, it goes right to my email, and I can reply back to you in webassign. And the biggest part that I like about doing this is that I can see your problem. I can also see what you've been doing with the problem. So, like, you type something in and it says you're wrong. I can see what you've typed in. I can see what the answer is, and I can compare them and say, oh, well, you know, you forgot the plus sign here. You forgot a minus sign there. Something easy like that a lot of times. Or it could be way off, and I could definitely help you with the math, you know. So I recommend that. It's in the top corner of every single problem, and it'll automatically email me. So that way I can get it, and I can go back and reply back. So, cool. Last one, F divide by G. You guessed it. I'm just going to take this and divide it here. Now, this is just weird looking with all the parentheses. I mean, but it does work. So, if you were to try to type this into webassign all at once, it's not going to make it look like that. It's going to make it look like this. And you got to remember the big division compared to the little division, okay? Those kind of things are very important. Often that's why I use parentheses to remind myself, look, it's a whole different division here, okay? So it could be a little bit big if you were not to simplify in webassign. That's why it's still good to know how to simplify, to be able to do that. Because sometimes, and I'm guessing at least some of us, are not good at typing a ton of symbols and fraction signs and all that kind of stuff. I mean, it's just easier just to simplify it on paper and then type in a much easier answer. I agree. I agree. That's not a problem at all. And so let's just say if I were to simplify this guy, you could do this, aside from my terrible handwriting. 6/8 can come to the front as a 3/4. And then I got x plus 8 over x. I guess you can kind of do some more simplifying. I don't know, distribute to 3x plus, 24 over 4x. I guess that's another way to do it. So there's a few ways to, make it look better. It's whatever. It's up to you. Okay. Now, what are the domains for these guys? Notice that I'm asking you right now, does this have any division? And you're going to say yes. Yes, that has division. So I need to know, when is the bottom, any bottom, equal to 0? Well, I'll have a bottom right there. So that's x equals 0. Or I guess you could say, like, x cannot equal 0. That's fine, too. Look, I have another bottom right there. Any bottom. All bottoms, any bottom. Hold on, let's go back up. See how it says x plus 8 equals 0? Again, set the bottom equals 0. Move the 8 over. X equals a negative 8. Again, I don't want to say equals, just, not equals. But these are the guys that we're trying to avoid. Those are my vertical asymptotes and all that kind of stuff. So how would I have my domain then? If you see it this way, again, this is just a review here. Negative infinity, positive infinity, as you're cruising through, negative 8's the first thing to come up, and then later you got a 0, and then you keep going. These guys, you cannot use these two numbers, but everything else is okay. So negative infinity up to the negative 8, union, negative 8 to the 0, union, 0 to infinity. That's your basic domain here. And I think that holds for this one, this one too, and this guy here, I think it's also the same. Notice, look right here at this guy right here, and I'm going to say, do we have division? And you're going to say yes. So I want every single bottom. So we got a bottom right there. We already accounted for that one. That's a 0. We got a bottom right here. That's negative 8. We already got that guy. And then we got this bottom. We often forget about that, but this whole entire thing is a big bottom unto itself. But really what you're going to be doing to find the 0 from that, or I guess you could say, is looking right here at its top. Because isn't that 8 right here technically in the bottom when I flipped it? You see that? Can I take this 8 right here and say 8, set it equal to 0? No, you can't. You just don't. So then you ignore it. And therefore, you have the same domain even for the last one. Okay. Now, even if you have to type them out or you have to click it, I can't remember, but this is your domain. That's your answer they're going to be asking for. 2.7.031. So f of x is equal to 2x minus 4. I got a g of x is equal to 5 minus x squared. They want the composition. So this is f of g of x, the fog, and the goff here in a few minutes. I don't know if you ever say those terms, but f of g of x. And what I often like to do is say f of g of x, because he's tiny. He's small. Yeah, I know. But this one's big. So I'm just being silly here. What I'm really trying to emphasize is the fact that this guy right there, he's inside. He's inside. He's just whatever he was inside of this f right there. Basically, this x right there, all of this fits inside of that. Okay, now I can go through the whole process and all the math. I think it's easier just to, like, literally graphically do this here. This guy gets shoved inside right there. So then let's rewrite it. 2 times something minus 4. Well, what's inside? 5 minus x squared. He's tiny. But that's it. You're done. That's your answer. I guess you can, write it proper, of course. You're tossing that dude inside. Done. The end. You don't need to simplify. Remember, don't need to simplify here. You're in webassign now. I think that was like part A, basically. This is part A. But part B, it says find g of f of x. Remember, this is g of f of x. He's tiny. And so I'm going to use a different color here. I'm going to take all of my f and shove it right there. Put it right inside that x. I'm just taking it all and just throwing it inside. Okay, so then we'd have 5 minus something squared. I mean, that's the format here, right? Isn't that 5 minus something squared? X It's the word for something in math land. But then what goes inside? Well, is the 2x minus, I'm sorry, 2x minus 4. You can see that these are like informal videos here. And we're done. You don't have to simplify any. You're good. Just, again, if you want to simplify, go ahead. That'd take you another 2 minutes. But that was it. That's the entirety of that problem. Again, these are all just review. I'm just reviewing you here. So, again, if you got questions, though, definitely tell me. So I have this G kind of does this kind of wiggly thing, and then I got an F that kind of does this like sharp angle thing. It's F. I am not going to make a perfect graph here. I'm just doing the best I can. What they're wanting is F of G of 1. F of G of 1. Well, notice again, F of G of 1. It's just G of 1. Right here. Like, let's find out what is this guy, find out what the number is, and then we can proceed. So what's G at X equal to 1? Well, then let's say X equals 1 is like right there. Dop, dop, da, dop, da, dop, dop. It's like that point right there. What's the Y value right there? Well, it turns out, I'm going to tell you, it's a 4. Okay, so just that's 1. That's X equals 1. And then it coordinates to 4. So what I can now do is rewrite that as 4. I could just say 4. The whole thing is just replaced with 4 now. Okay? We didn't need that X there. I was just kind of demonstrating there. 4. That's it. Well, now hold on. What are they wanting? Well, F at 4. That's my X value again. That's an X equals 4, right? So then that's 2, 3. Oh, I think I went to... Here, let me try to zoom in out a little bit. 1. That's 2, 3, 4. Okay, this is my 4. Okay, this is going to be closer to what you have. So if you do this and coordinate it off, it actually ends up that this is a 2, a height of 2. So that's your answer is 2. So let's just try to do this problem one more time. Okay, I'm going to use a different color here. So I'm starting at 1. Notice the 1. I'm starting at 1, and they say start with a G. So I go up to the G, and I find that it's at 4. Now I can replace that thing with a 4 and say, okay, now they want F at 4. So I'll say, okay, start at 4, coordinate it off, and it ends up at 2. Oops. So there we go. That's how I got it. They're going to now do, I think this is like part B or something, they were going to do F of X. F of X. So that's kind of weird. Let me just tell you, that's F of, oh, I don't know. Let's just do 4, because that's something I already know. Okay. Like, here's just an example. I can't remember if this is exactly what it is. I have something like this on my paper, but it's not, I just basically stopped. So let's just say I'm going to do this part here. Well, F of 4, I already got that. The answer's 2. So I can just replace that inside part with 2. But now they're wanting to find out what is F at 2. Well, I'm going to use a different color here. 2 is right there. Isn't that 2? So what's my F value? Well, I actually have to go down and then back over. Say it's at -1, let's say. That's an easy number. So -1. There you go. Ta-da. Just watch out for the letters. Because, I mean, we're so used to just doing F of G of X, call it a day. They'll do G of F of X. They'll do F of X, and who knows. Just watch out. That's what I have on my paper here. I said watch out. Watch out. Okay. 2.7.045. So this is some kind of table. I got X, F, and G. I don't even see any lines. It's kind of confusing to me, honestly. But we are going to do this here together. So many numbers. Everyone's getting different numbers, by the way, on your homework. That's why it's okay for me to do them, because you're going to have different numbers, different answers. Same procedure, though. Okay. What they're wanting here in this particular problem is F of F, not two different Fs, F of 5. They say, what's that? Well, I mean, that's kind of confusing to me. I don't like this format anyway, so I just rewrite it like this. So I'm trying to find F of 5. Well, notice I'm starting with the 5, and I want F. So it's kind of like you're coordinating it off, like 5 and F, coordinate it, and you get a 6. Okay, you see that? Coordinate it to a 6. So then I can replace this with a 6. And now I'm saying, okay, well, I got a 6. Cool. Now I'm wanting to say, well, I'm going to start at 6, and they want F again, so I'm going to do F and 6, and it ends up being right here at 1. And you're done. That's it. It's not too bad, honestly. It's pretty easy. I'm going to say, don't overthink it. If this is like, man, this is confusing. Well, I mean, yes, I understand we're trying to get back into it and stuff, but this is honestly no different than what you've done in the My Math Lab, algebra class that you came from. So I'm hoping that a lot of this seems like review. If it seems kind of foreign, or maybe it's like been a few years, or maybe you've even had this class at a different college, just that's okay. I know we're getting into it. So practice, do the homework for yourself, and as you go along, if you're having problems, just message me, and we'll figure something out. I'm here to help on anything. Okay. The homework is designed for practice. It's designed for you to go through and, oh, now I see. Like, that's the point. The point of the homework is okay. And so, it takes a little bit sometimes to get the concepts. Sometimes it doesn't take hardly any time at all. I mean, when I'm looking at this, I'm thinking, oh, this is not a big deal. But, I mean, if it is a big deal for you, I understand, and I'm here for you. And I'm going to make it not a big deal. That's my job. So, anyways, and I can only do so much on a video recording. Obviously, it's kind of static, And so here we go. Next question. We got these two functions here, and they're wanting f of g of x. Again, I don't like that format. I like to rewrite it like this. What is my g? Actually, just no. I used to do that in algebra a whole lot. I think it's almost a little bit confusing. I want to take my inside. Remember, g's on the inside. And I'm going to just throw it inside right there. Just toss it inside. Just shove it in there. There you go. And, well, we're done. That's it. You could simplify. Obviously, some 2's will cancel and stuff, but that's it. So remember, we're looking for a domain on a lot of these things, so I have to figure out what the domain is. My question to you is, do we have division? I'm going to say yes. And so then I have to take the bottom, equal to 0. And I move the 6 over, divide by the 2, and I get a -3. So it's, again, not equal to -3. It's kind of like a vertical asymptote or a hole or whatever you want to call it. It's a negative infinity, -3, union, -3, to infinity. That's my answer for the domain. Wondering if I'm going to get a square root answer eventually. Yeah, that's coming up right here. Next question, 2.7.056. So I don't know why I start in part B. I think it's just because I've been doing a whole lot of part A's. I want to do a part B maybe. I don't know. But I don't even have part A on my paper. I just start with part B. So that's g of f of x. Again, g of f of x. And so I'm taking this f that's on the inside, and I'm going to put it right there. Okay, I'm just going to replace that x with all the stuff. Even squaring it. So I got this. Okay. Actually, hold on. I did one small mistake. Did you notice? We've got multiple x's that you need to plug into. Normally, we just have the single x. Okay, we're good. But like we have multiple x's that we need to plug into here. We plug them into both. And so we have this twice. See, that's an easy mistake, especially when we've been doing it so much just with a single term. And they throw two terms at you. And that's probably why I started with the part B, because it was a good question. So I even messed up, see? So there you go. That's okay. We're learning together. Well, technically you're done. You don't have to simplify. Obviously you could. But I'm not going to care about that so much. I'm really caring more about the domain. So I'm going to ask you the same questions I always ask. Do we have any division? Do we have any division? And you're going to say yes. So I need to see whenever the bottom is equal to 0. Any bottom. Well, like, here's a bottom. There's another bottom. If you simplified it, it would just be an x. I mean, that's fine, too. So let's just take the square root x, I guess. It's fine. And I'm going to set it equal to 0. Well, I mean, to get rid of the square root, I'm going to square both sides, just like I was doing here anyways. And so x equals 0. I technically not equal to 0. That's a vertical asymptote, and there we go. We're going to use that here in just a second. I'm going to ask you another question. Look at the answer here. Do I have any square roots? And the answer is yes. I finally have square roots. I mean, it's right there, right there. Again, this would cancel, but I'd still have one left over for sure. So then I need to take the inside of those square roots and set it equal to 0. Okay, so I'm going to take the inside of the square root, this guy right there, right there. I know that's kind of small to see, but it's just x. X is equal to 0. The inside of the square root is equal to 0. Sometimes we have like elaborate things like, I don't know, 3x minus 5. And then you take that dude and set it equal to 0. Well, we don't have that here. We just have x. So x equals 0. We're done. This is actually going to be a start point. Again, that's just kind of my term for it. Normally with the start points in square root, square brace, you're using these square braces or brackets as part of your domain. But with the vertical asymptotes, you're always using parentheses. So it's kind of weird. Notice that we have x equal to 0, I should be using parentheses. X equal to 0, I should be using a square brace. So which is it? And so you can definitely do this thing. I don't know. We don't often do this thing. I'm going to go and write it. Double check. No way. Yeah, sometimes we actually have to do this double checky thing. I want to know in my answer here if 0 is actually going to work or not. Am I going to include it? Oop, not inside. Include. Is include? Yeah. Yeah, include starts with an I. Include it with the square brace, or am I going to exclude it with parentheses? That's kind of the question here. Is 0 a good number? Is it something that's going to give me an actual number if I plug it in? So I'm going to say, okay, well, x equals 0, plug it in. So then I got square root 0, square root 0. Well, as we know, square root of 0 is 0. So we got 1 over, if you square it's the same thing. And then here we got same thing. Look, we got divide by 0. And this is undefined. So x equals 0 is not a good number. So do not include. Include. There you go. That's how you spell it. Do not include. Therefore, we will definitely be using the parentheses with our x equals 0. So then finally, what's my domain? I'm going to give you the answer. It's 0 to infinity. And the reason why I can quickly do that is because I think back to the start point. The start point is a very quick way to do this with the square roots. This is just my little cheater method. I go 0 to infinity, call it a. If I had a start point at 3, 3 to infinity. Had a start point at -5, -5 to infinity. Just put the number there, go to infinity, and we're good to go. Okay. Same kind of thing here. If you remember, we should be using these parentheses here. But notice that this is almost overlapping this part. And there's no other section over here like this one was. So where do they both overlap? And it's actually this zone. It's the only place where they both have something in common. Yet, we already know not to include that 0, therefore parentheses. And that sounds like a lot going on. But again, I'm telling you, this is review. So if it's kind of a distant review, maybe you've heard some of these things before. Maybe it's been a long time. I understand, it's not like we're going to be doing this literally every day, but it is something that should be in the memory bank somewhere, at least to some degree, okay? Another way, just real quick, to double check all this stuff is to actually get out all of your intervals, list them out, and just test them all. And so I'm going to test. This is kind of the really, really slow way. I'm going to test -infinity to 0, 0 to infinity. I want to test, I don't know, let's say x equals -1. And x equals 1. And heck, let's just test that number right there, x equals 0. So when I plug all these in, I'm going to say, and I'm going to do it, I'm going to plug this in. Sorry that it's taken so long. If you're bored at this point, skip ahead. And so, moving on. That was just a joke. So when I'm plugging in -1 into a square root -1, is that gonna work? Now some of y'all are saying, oh well, that's that's an imaginary number. Well, that's very true, but I'm going to tell you, does your TID3 say that? Does Desmos say that? No, they're going to just say undefined. It's error, you know what I mean? So that doesn't work. None of this stuff works. We already tested this guy. Remember we plugged it in? That didn't work. What about plugging in 1? I'm just testing 1. You can try 2. You want to try 2? Let's do 2 instead. I'm just saying pick a number that's somewhere from 0 to infinity. I don't know, pick 20. That's fine also. Whatever number you want, you plug it in, and let's see what happens. So I got a square root of 2, let's say. Square root of 2. Now, I have no clue what this number is, but it's a number. Check it on the calculator. You get a number. Cool. We like it. Great. This guy's awesome. And that's the only answer that we have. Everything else was you got rid of that. You got rid of that. This is the only answer we got. And that's how I got it. That's how I got my answer. Okay. Keep moving. I got a couple more questions, actually. So 27059. I probably won't be as talkative about like webassign and technical issues or review most of the time, I guess. But I just wanted, because it's our first one, I just want to make sure that you're understanding where I'm coming from on this stuff. This is the lecture experience. Now this is strange. F of G of H, and those little 0 circle things, those are of. What they're really trying to get at is F of G of H of X. Notice that we're going to have this, and then this, and then this. So it keeps expanding out. Well, H is on the very inside, and I'm going to plug it in. I'm going to substitute it in with that one. Okay, so let me go and do that right now. This is G of H of X, square root of X minus 6. So that's this portion right here, okay? But then I got to take this, whatever I had from this stuff, I got to plug it into that X. And so then I got F of this G of H of X is now, here we go, this is what it's blank minus 6, right? That's what it looks like, blank minus 6. Well, I'm plugging that in, square root of X minus 6. So that's my answer. Notice that one's on the inside and one's on the outside. Very careful typing in webassign. Okay, very careful. Okay, 2 problems left. 2.7.063. So capital F of X is equal to X minus 6 squared, and they're saying that this is equal to F of G of X. What they want is F of X and G of X separated. Now this is what it looks like on webassign. Notice that they give you the parentheses already and they give you a box. You have to type a comma in there at some point because we're going to separate these two functions. Again, I don't like the format that they're going through with this. I'm just going to try to do this right here. So F of G of X is equal to X minus 6 all squared, okay? Notice that we have this guy is on the inside. Inside. I'm going to ask you, looking right here, what's on the inside? If you had to say something, what's on the inside, what would you say? You would say X minus 6. It's the stuff inside of the parentheses. That's my inside. That's what I would say. So this right here, this guy, this is G of X. That's the second part of your answer right here. Okay, I put a comma right there, by the way. Well, that's my G right there. I still need my F. So, like, what I'm going to do is replace this inside with stuff. I'm not kidding you. Stuff. Stuff squared. Stuff. I mean, whatever that is. Inside, stuff. What do you use? What's the letter you use in math land for stuff? Like, what are you going to use? Use X. X squared. This is your F of X. X squared. There you go. It almost just like magically appeared. Okay? Really, all we're doing here is we're going backwards. Okay? Going backwards. You can't read it, but I told you. So we're going backwards. we're seeing the finished product, and I'm saying, okay, well, what was on the inside and what was on the outside? If you're looking right here, and I'm going to ask you, what's on the outside? You're going to say, well, it's the square. And you're right. It's something squared. Okay, there you go. 2.7.077, this is my last question. So they're trying to make this into a word problem. They got a stone that is dropped into a lake, and there's a ripple effect. Okay, so like the ripples coming out. It has a speed, each ripple has a speed of 70 centimeters per second. I don't know if that's fast or slow. I'm just saying we got a ripple speed of this much. Now, the questions are quite confusing on this, and that's why in particular I wanted to show you this question, okay? Not because it's hard, but because it was just confusing. What do they want? So they're going to ask first off for radians. And I'm like, what? What are you talking about? No, not radians. I'm sorry. That's my handwriting so bad. I was thinking radians. Radius. Radius. Sorry about that. What's the radius? Let me just give you the answer. It's 70t. Basically, for every second that you put into this thing, it's going to grow 70 centimeters or whatever. So you tell me the time, and I'll tell you how much, size this thing is. Okay. B, it says, now find the area. Now, this one's very nondescript. It does not really say anything. So this is why it's confusing. I'm going to tell you, you put pi r squared in the answer. Where did that come from? But that's okay. I mean, there are some questions that are a little confusing. And I'm going to tell you, this is a strategy that you might have also done back in the college algebra stuff. But if you go and get the problem wrong a couple times, often they'll give you the answer. I'm pretty sure they do. They'll give you what the answer is, and then they'll let you try again, a new randomization. And so let's just say you're just not getting part B, because it's part A, part C. They're pretty easy here in a minute. But what if you're just not understanding what they're asking for? Like, what are they wanting? Well, go get it wrong 3 or 5 times, whatever the settings is, and then they'll give you the answer. And they'll say, oh, yeah, pi r squared. And you're like, it was pi r squared the whole time? New randomization. It won't be 70 anymore. It'll be like 80 now. And then you just redo the same thing. You just put an 80 there. And then you know where to put now in part B. It's pi r squared. So I'm trying to make an easy strategy for you. We're not cheating here. I'm just saying some of the questions are a little bit weird about what they're asking for, and so we need to go back and say, oh, that was what you were asking for, because it didn't indicate. They didn't indicate. So try to use technology, the computer, to your advantage, F of G, what is that supposed to be? So, again, what are they asking for here? They're technically saying to take this, and we're going to plug it into the R, okay? Now, I have a simplified version on my paper, but essentially what's going on is that you're putting this guy in here and squaring it, and so it looks something like this when you simplify. Again, you don't have to simplify. I just thought it looked cooler, so, well, there you go. All right, that's actually the last question I have in this section. I'm going to do a mini lecture like this for each one of these sections. That's at least the goal. So, if you have any questions at all, let me know. Email, Blackmore message, ask my teacher on webassign, whatever it is. I'm here to help you. Thank you very much. Have a great day.